Have you ever just stopped and wondered how a machine can learn to spot a cat in a photo or even how to drive a car without a programmer sitting there and writing millions of lines of code for every single possible scenario? Well, that's the incredible idea we're going to break down today, how AI learns without someone having to program every little detail. Let's get into it. So it all really starts with this one fundamental question, the one that changed everything. Seriously, think about it for a second. How would you actually write code to describe, say, the vibe of a sarcastic comment, or the tiny, subtle differences between a golden retriever and a Labrador? For so many things in the real world, it's basically impossible. And that's exactly why the old way of doing things eventually hit a brick wall. So let's start with section 1, the limits of code. We're talking about the old paradigm here. For decades, programming was, pretty straightforward. A human, a programmer, had to think of every single possible rule and then write it down line by line for the computer to follow. And this image, well, it just shows the power and the weakness of that old way of thinking perfectly. Imagine we want a computer to figure out what a person is doing. Okay, for walking, the rule is simple. If their speed is less than 4 miles an hour, let's call it walking. Easy enough, right? For running, we just add another rule. But then, what about biking? Okay, the code gets a little more complex. But now, what about golfing? How do you even begin to describe the motion of a golf swing in simple if-then rules? You just can't. The whole system of writing explicit rules just completely falls apart. And that is the exact wall that programmers slammed into. For really hard problems like understanding images or human language or playing super complex games, the rules are either way too massive to write down, or honestly, we don't even really know what the rules are ourselves. We needed a totally new way to think about it. Which brings us right to section 2, a new way to learn. This is the big paradigm shift. This is where machine learning steps onto the scene. And it's not just some new technique. It is a fundamentally different way of getting computers to solve problems. Okay, this slide right here is everything. This is the whole ballgame. On the left, you've got traditional programming. We give the computer the rules we wrote and the data, and it just follows our instructions to give us answers. Simple. But with machine learning, over on the right, we flip the entire thing on its head. We give the computer the data and the answers up front. So we show it thousands of pictures of dogs, and we tell it, these are all dogs. And then we tell the computer, you figure out the rules for what makes a dog look like a dog. The crucial point is we're not teaching it the rules, we're creating a system that lets it learn the rules all by itself. So how in the world does it figure out the rules? Well, it's actually a pretty simple but really powerful loop. The machine makes a guess, then it measures how wrong that guess was, and then it tweaks its own internal logic just a little bit to make a slightly better guess the next time. And it does this millions, sometimes billions of times, getting a tiny bit smarter with every single repetition. So that brings us to section 3, 3 flavors of learning. Now that we kind of get the big idea, let's look at how these machines actually learn. You can think of these as 3 different teaching styles for an AI. First up, we've got supervised learning. This is the most common one you'll see. The best way to think about it is like you're studying for a test, but you've been given a complete answer key. You give the machine tons of examples, and for every single one, you give it the correct answer. For example, you show the AI this picture right here, and you explicitly label it dog. And then you do that thousands and thousands of times with all sorts of different dogs in different places, different lighting. Now, here's the really important part. The machine isn't just memorizing the pictures. It's learning the underlying patterns. The floppy ears, the wet noses, the wagging tails, all the things that actually define what a dog is. Next up, we have unsupervised learning. And as you might guess, it's the total opposite. It's like giving someone a giant mixed-up jigsaw puzzle, but with no picture on the box to guide them, and just saying, okay, find some groups that make sense. The AI has to discover all the structure by itself. A classic example of this is sorting through customer data. You can feed an AI all of your company's purchasing data with no labels, no hints, and it might start to discover little clusters of customers all on its own. It might find your weekend shoppers, your bargain hunters, or your big spenders, patterns a human analyst might have completely missed. And the third flavor is reinforcement learning. This one is all about trial and error. Honestly, the easiest way to think about it is like training a puppy. When it does something good, you give it a treat. When it does something bad, you give it a firm no. The machine is constantly trying to perform actions that will maximize its rewards. A self-driving car is the perfect way to picture this. The car is the agent, and the road is its environment. Every time it makes a good move, like staying perfectly in the center of the lane, it gets a small reward, a little positive point. But if it makes a mistake, like touching the line, it gets a punishment, a negative point. After running through millions of these simulated miles, it develops a strategy that gets it the highest score possible, which just so happens to be the strategy for driving safely and efficiently. All right, section 4, refining the AI mind. So we've got these really powerful learning methods, but how do we make sure they're actually useful and, safe for people to interact with? Well, that takes one last crucial step, especially for things like ChatGPT. This extra step is a technique called RLHF. That stands for reinforcement learning with human feedback. So after the AI has done all that initial learning from a huge dataset, humans actually step back into the loop to guide it. They'll look at different AI responses and rank them, basically telling the model, hey, this answer is way more helpful, or that other answer is safer. And this quote here from Zapier just sums up the goal perfectly. It's not just about being smart or getting the right answer. It's about making the AI's responses safe, sensible, effective, and coherent. You could almost think of it as a finishing school for AI. It teaches it not just how to be smart, but how to be a helpful and harmless partner for humans. And that brings us to our final section, the learning revolution. When you put all of this together, it becomes pretty clear that we've moved from a world of just giving computers instructions to a world where we can build a kind of digital intuition. And that shift allows machines to tackle problems with a level of complexity that we could never, ever code by hand. I mean, the perfect example is the ancient game of Go. The rules are pretty simple, but the number of possible moves is, well, it's a number larger than the number of atoms in the entire universe. You cannot program a winning strategy for that. But an AI like AlphaGo can learn one just by playing against itself millions of times until it eventually became better than the best human players in the world. So, if there's one key thing to take away from all this, it's this really simple but profound difference. With traditional programming, we write the rules. With machine learning, the machine learns the rules from examples. That one single fundamental shift is what unlocks AI's ability to solve problems that we used to think were completely impossible for computers. And that leaves us with a pretty fascinating final thought. Now that we can teach machines to figure things out without having to spell out every single detail in code, what's next? What huge challenges in medicine, in science, in art, things that were once way too complex to even think about, are now suddenly within our reach? That is the exciting future that this learning revolution has made possible. Thanks for diving in with me on this explainer.